actually the Democritus idea can be proved. How can we prove it? One thing is the discontinuous nature of matter. Discontinuous nature of matter. What is discontinuity? It's this way. I mean, let's talk about then kind of this solid. I mean, here, this marker, you can see it. Can you see any empty spaces within this area? Can you see it? No, no one can see it. Understand? So, but actually, if you can go to atomic level, that range, microscopic scale, not macroscopic. Macroscopic here, we see this one like continuous. But no, there are some empty spaces. If you can go to atomic level and see, this is made up of some atoms, molecules, combination. But in between atoms, we have some empty spaces. Therefore, although this is solid, this is discontinuous. The water sample you take, let's say you have a glass of water and then it is halfly filled with water. When you look at that one, you will see its entire area then water, but it is not. That area, that sample is composed of water molecule, but between water molecules, there are some empty spaces available. It is discontinuous. Let's take then gas balloon, hydrogen gas balloon. Once you fill the balloon with hydrogen, you can believe that entire area filled with hydrogen molecules, but it is not. Between hydrogen molecules, we have large empty spaces in the case of gaseous state. Liquid state, the size of the empty space smaller than gas, but in solid then even small, but still empty spaces available. That is known as actually the discontinuity of nature, of matter. We can prove it. We can prove gaseous state of matter is then discontinuous. By doing simple experiment, we can prove. One famous one is then diffusion. One famous one is then diffusion. Diffusion, I will explain it, don't worry. Even in the gaseous state of matter, unit 4, I will come back to this one. Diffusion is one simple phenomena. Diffusion. Assume you have a vessel A and vessel B. These are closed vessel. And it is connected by very thin glass bulb. And in the middle, there is a tap. This A bulb is filled with, let's say, carbon dioxide gas. Carbon dioxide gas, but with high concentration. This one is carbon dioxide gas with high concentration. Let's say the other, I take next B vessel. Let's say B vessel filled with another gas. I use then green color. Can you see green color? Maybe you can see it. Yes, you can see it. Right? This one is actually different gas. Let's say hydrogen gas. But here the concentration of hydrogen gas is quite low. Small number of hydrogen particles available. Here large number of carbon dioxide particles available. Now the tap is closed. Then there is a barrier. These particles cannot move here and there. Now what I do? I open the tap. Once I open the valve, I open the tap. What can you observe? Can you tell me which gas particle starts moving first? Generally, it's carbon dioxide gas particle or hydrogen gas particle. Once you open the tap, can you predict it? Which gas particle will move first? Can I have the answer? Can you understand my question? Two vessels are there. One vessel completely filled with carbon dioxide, and I said here concentration high. Here there are large number of carbon dioxide particles. This vessel filled with hydrogen gas, but here concentration low. Small number of gas particles available, hydrogen. Then we have a tap. Then movement is then restricted here initially. But what I do now, I open the tap. When I open the tap, open the valve, now gases can freely mix each other. All right. Then my question is this. According to the explanation conditions here, which gas will move first? Which gas starts moving first? Whether it is carbon dioxide or hydrogen. What do you think? Okay, I can see correct answers. What about the others? It's okay whether your answer is correct or wrong. I don't care about that. But what I need is your response. Yeah, all of you. Yeah, I got yes responses, and all the responses are correct. Yes, it should be carbon dioxide. The reason for that one, here high concentration, high pressure, right? here low pressure. In that particular case, once you open the tap, definitely the high pressure particle, they are under tension. They don't like to be in that manner. They need free space. And then what happens? Carbon dioxide particles will move from A vessel to B vessel. From A vessel to B vessel. That's what happened first. That phenomena is known as diffusion. Now you can see carbon dioxide particle even in B vessel. So B vessel has hydrogen, we know that one. But in between hydrogen molecules, you can see carbon dioxide molecule also. That is known as diffusion. Diffusion is the process where the particle of gas particle, I mean, let's say particle of one gas, move from higher concentration place to low concentration one, or move from one place to the other as a result of concentration gradient. In that particular case, mainly the particle of one gas particles will go through the spaces or empty spaces available in the other gas particles. So then it's very clear then evidence to show that hydrogen gas is discontinuous. Okay? Only if you have empty spaces between hydrogen gas particle, these carbon dioxide gas particle can move. Then we can say hydrogen gas is discontinuous. Not only that, once you leave the system like this, even hydrogen gas particle can come here. Right? This happens until the pressures of two bulbs are equal. We'll come to that later. Once even the pressures are equal, still the particles can exchange. So hydrogen gas particle can come here. They can go through then empty spaces available in carbon dioxide gas sample. Means carbon dioxide gas is also discontinuous here. We can prove it in that way. Got it? So therefore, from this simple experiment, we can say gaseous matter is discontinuous. Means gaseous matter is composed of tiny particles. There are empty spaces between these particles. Right? Anyone has any doubt regarding this? Anything you didn't understand or any confusion here? Yeah, I see some of you left and come back, again left, come back. Maybe network problem. Eh? Problem. Right, it's okay. So I hope you understood the discontinuous nature of gas and how to prove it. Shall we complete the note and go to the next one? How H2 goes to a vessel if it has low pressure? Yes, actually, initially hydrogen will not move. Right, hydrogen will not move to A initially. Initially, then carbon dioxide particle try to have space because of high pressure. It needs more volume to reduce the pressure. Then carbon dioxide particle will move to B vessel initially. But thereafter, once the pressures are equal and settle down, there is no barrier in between these two. There is no barrier. Both of vessels have same pressure. And these particles in gaseous state of matter, I will explain. The attractive forces between particles then very weak. Then one particle can quite free, independent. Then it can just move here and there like this. No force. Freely it can move here and there. In that case, definitely you can find hydrogen particle in vessel A also because of no attraction, weak attraction part. In gas, we will discuss it more and then you will understand that. Start the note like this. Start the note. Here we write then kind of experiment. Write it like this. Consider a vessel A and B vessel, WESSEL vessel. Consider a vessel A and B which are connected by a thin glass tube. Consider a vessel A and vessel B which are connected by a thin glass tube. A thin glass tube. Vessel A is filled with carbon dioxide. Vessel A is filled with carbon dioxide with high concentration. And if I am too fast, let me know. If you can't catch the note, then let me know. I can repeat it. Vessel A is filled with carbon dioxide gas with high concentration. Vessel B is filled with hydrogen gas with low concentration. Vessel B is filled with hydrogen gas with low concentration. Initially, the tap is closed. Initially, the tap is closed. Initially, the tap is closed. Okay, then start a new point. Then start a new point and write this one. After the tap is open, after the tap is open, after the tap is open, first carbon dioxide particles will move from vessel A to vessel B. First, carbon dioxide gas particles will move from vessel A to vessel B. This is because of high concentration of carbon dioxide. This is because of high concentration of carbon dioxide. During this process, just continue it. During this process, carbon dioxide gas particles go through the empty spaces available. In this case, carbon dioxide particles go through the empty spaces available among hydrogen gas particles. Empty spaces available among hydrogen gas particles. Then start a new point and write this. Hydrogen gas is discontinuous. Hydrogen gas is discontinuous. From the observation we got, then we can conclude it. Hydrogen gas is discontinuous. Okay. Shall we draw this one? Then I think you have space available. In the remaining space, then just draw this one. Initial system and the final system. Use two different colors clearly. If you can't see the board clearly, I shared that one in chat also, the screenshot. You can refer that one also. Right. I think you completed it. Ne? Done. Okay. Right. So that's about the gas diffusion. Using that concept, we can easily prove that gaseous state of matter discontinuous. Let's move to liquid and solid also. Actually, today then I will then our usual class time is 7:30 to 10:30, 3 hours class, right? So be the first month, I will not go to 3 hours class. I will do 2 hours classes. Maybe this day, next day, or maybe within this month, I will do only 2 hour classes. But thereafter, I will increase that to 10 hours, right? Sorry, not 10 hours, 3 hours. Today, then I will do only 2 hours class, because at the beginning, then have you been there? I mean, is this your first time in 3 hours class? Or you have already participated 3 hours class online? Have you then experienced 3 hours online class? Yes. No, some of you know. That's the case. So in the case of online, actually, not online, only physically. Yeah, that's the case. Then in online, you may take about 1 month, 2 months to then familiar with this method. You need that time. Definitely, you need that time, because some of you are okay with online, some of you are then not okay. Because of that, they need time to adapt this environment, this method. Sometimes you can't look at the screen a long time. Right? We have that problem also. Right? Not someone, then most of us cannot look at the screen for 3 hours consecutive. So we have to take it out and have a small rest, and then only come back to this one. Someone then cannot stay in one place without any sound around there. If it is a class, then we have some sounds. We can look at the other person's movement and everything. But here inside the room, then only you sometime. Then you need time. That's why I slowly increased the class time to 3 hours. So actually later in 2021 class, I remember I did even 4 hours class, but that's not successful. Then I stop it, and then only 2 hours online and 3 hours. Therefore, in first month, it will be quite 2 hours, but later I will increase that 1 to 3 hours. But today we should complete this discontinuous nature. Then next day we can start with a new topic. It's about electrical nature. That's also something to prove particle nature. I mean, the Democritus one. Discontinuous nature and electrical nature. These two. Before we go to Dalton, better we have that idea. This is an experiment actually. Thereafter we can go to next model. Right. Here, a liquid then. Once you consider liquid, still it is discontinuous. Like gases, then we don't have large empty spaces. In gases, we have very large empty spaces, right? Another thing, actually, another experiment, if you want, let's say you make hydrogen sulfide gas in the laboratory. Right? I don't know whether you have that experience. Normally, in our degree program, actually, first day we went to the inorganic chemistry laboratory. Then 3 hours practical time. Then our first experiment was that cation analysis part. But we learn in all A-level. A-level in organic, you have that one, right? But we don't do that experiment in the laboratory in A-levels. You need the theory only, you learn. But in the university, first experiment was that one. Then to pass hydrogen sulfide gas, we have to make hydrogen gas, hydrogen sulfide. For that, what we did actually, we were given iron sulfide solid. Then we add hydrochloric drops to that one, acid. Then it produce ferric chloride and release hydrogen sulfide gas. Nomenclature, writing formula, equation, everything will be discussed later. Here, then it produce hydrogen sulfide gas. Let's say I'm in one corner and I produce hydrogen sulfide. But then other corner person cannot smell it, because in between these two corners, the area is filled with what? Air. I mean nitrogen, oxygen, these are matters. If that is continuous, no empty space available, this hydrogen sulfide particle cannot move from one corner to the other. Then the other person, my friend in the other corner, cannot smell hydrogen sulfide. But what happened? Within few seconds, what happened? Entire room, entire laboratory filled with that hydrogen sulfide. What about that smell? It's a pleasant smell or very bad smell? Hydrogen sulfide, very bad smell. We can't tolerate that one. So actually, I remember some of girls then ran out of the laboratory. They stopped all the experiment and ran out of the laboratory because of that. Some people then cannot tolerate this one, stand for this smell. So that's because what? Again, that air is discontinuous. The air filled between two person is not continuous. Empty space available. That's why hydrogen sulfide particle go through those air particles. If you use perfume, other person can smell it. That's because air is discontinuous. So likewise, then I can give large number of experiments, simple experiment to prove that air is discontinuous. Yes. Rotten smell. Yes. Maybe you have done that experiment. Eh? Some of you maybe have done that experiment in laboratory. Yes, rotten smell. We can't tolerate it. So that's again discontinuous nature. Likewise, I can give large number of examples, but let's move to then water part and solid part and finish it. So once you consider water part, then you have a clean, clear beaker here. This is filled with water, clear water. It's pure water, clean water. Then we can see this. It's transparent. We can see everything clear. So now what I'm going to do, I try to add a small amount of potassium permanganate. You know something about potassium permanganate in O level. The formula is KMnO4. Potassium permanganate. Huh? Do you remember the color of this potassium permanganate? Anyone remember color? Can I have about 1 or 2 response? Color of potassium permanganate? Yes, you remember, eh? Purple. Good. Purple color. Yes, good. So then the thing is this one. Once I add potassium permanganate to this place, you can see here I took green color. I don't have purple color, so that's why I use green color. Let's say I add a small amount of potassium permanganate to this place. If this water is continuous, no empty space between water molecule, these KMnO4 particles, they don't have any chance to spread because there is no space. Then how can they go? Water molecules everywhere. Then these particles cannot go through this area. But what happened? Once you put it, you can see slowly this purple color then spread to all direction here. So what's the meaning of that? KMnO4 particle, actually here not K, permanganate is the ion responsible for purple color, not potassium. Then permanganate ions then slowly go through these empty spaces available in water. Then from that experiment, simple experiment, we can say, then there are some empty spaces among water molecule, then water is discontinuous. Liquid matter discontinuous. That means that matter again made up of tiny particles. There are empty spaces among these particles. We prove again the Democritus one idea. Right? It's very simple experiment. Water is discontinuous. Okay. Let's try the note for that one also. Now you are here under discontinuous nature of liquid. Start the note like this in that place. Consider a beaker containing pure water. Consider a beaker containing pure water. Pure water, then you know it's clear, transparent liquid. Consider a beaker containing pure water. If a small sample of potassium permanganate, if small sample of potassium permanganate, if small sample of potassium permanganate is placed in this water sample, is placed in this water sample, the purple color spread throughout the liquid sample, spreads throughout the liquid sample, spreads throughout the liquid sample slowly. Spreads throughout the liquid sample slowly. This is because right, like this permanganate ion formula is MnO4 minus. The name is simply permanganate ion. This is because permanganate ions This is because permanganate ions move through the empty spaces available. Move, M-O-V-E, move. This is because permanganate ions move through the empty spaces available among water particles or water molecules. Right? This is because permanganate ions move through the empty spaces available among water molecules. Then start a new point and write water is discontinuous. And that right, water is discontinuous. Water is discontinuous. All right. Then we prove that liquid state of matter is also discontinuous. If you want, you can draw this one roughly. You can draw it like at the beginning in one place, but after some time, what happened? That spread. This one then spread here like this. Finally, entire area is then purple. Right. I hope you complete that one. So next part, then last thing is to show that solid is also discontinuous, but then it's quite difficult. I mean, in the gases, then definitely we have large empty space. Even we can compress the gas because of discontinuous nature, because they have empty spaces. Liquid also, then we have somewhat, large empty spaces up to certain extent, not like the gases, but definitely more than solid. Solid, the particles will be closely packed, strongly packed. But although it is closely packed, still you can see some empty spaces between these two particles. They can't undergo movement. This particle doesn't move, but there is vibration here. That's vibration, right? But we have to prove this one. We are talking about experiment. How can we prove this one? It's this way. This is a kind of simple experiment. I'm talking about very simple one, right? Let's take a piece of gold, small piece of gold. Nowadays we can't do it. It's quite expensive. Earlier in ancient time, it was cheaply available. Then this piece of gold is kept with a piece of copper, strongly connected, these two are in contact. These two are kept in this manner for several days. Then what we can observe after several days, actually, when you look at the piece of gold very carefully, you can see about 2-3 maybe copper particles. You can observe this one. Gold color, it's bright yellow like that, golden color. But what about the color of copper? Color of copper will be like pink brown color. Then definitely 2 different colors. So you can see some copper particles have entered to the piece of gold. It happens. Not the large amount of particles, but very small number of particles then enter to this area. That's because there were some empty spaces between gold atoms. Then copper atoms can enter this area. Not only that, even if you look at piece of copper, you can see some gold particles available in that copper piece also. So that is another experiment. We can prove that both copper, gold, then discontinuous. Although it's solid, still it is discontinuous. So remember, then any matter, even ourselves, made up of particles, there are some empty spaces among these particles. Then we are discontinuous. When you consider your wall, your room has several walls. Actually, it is discontinuous. There are some empty spaces. To our naked eye, then we can't then see that one, that small part, but still it is then discontinuous. Remember that. Okay, let's point out that one also and finish this. Write it like this. We are under then solid part. A piece of copper and gold, a piece of copper and a piece of gold are kept in contact for long time. A piece of gold and a piece of copper are kept in contact for long time. For long time. At the end of this time period, these two are separated. These two are separated. If the piece of gold is carefully examined, if the piece of gold is carefully observed or examined, if the piece of gold is carefully examined, we can see some copper particles inside the piece of gold. We can see some copper particles inside the piece of gold. Same thing here also, but here I don't write it. Then start a new point and write this. Gold is discontinuous. Gold is discontinuous. So gold is a solid, then solid is discontinuous. Same way we can prove copper is discontinuous also in the same experiment. So if you want, you can copy this part also. Rough diagram. Earlier this, then later this. Okay, done. Okay, then, being the very first day today, I did not then discuss advanced concepts there. Very simple one, maybe already you know that one. But it's a good approach. We should anyhow start it. This is best place, I think, to start A-level chemistry. So without going to very complex, then a complex concept, this is the best way to start it. This is the best way to approach A-level chemistry. So then those who have some doubt whether you can continue chemistry or not, that means if you have a good understanding about O-level science concept, right? Maybe your marks in the O-level exam low, but you have the concept. There are some students like that. They have the concept in their mind, but they can't deliver that one. I mean, they can't take that one out and write the answer correctly. Because of that, they lose mark and have low result. But still, they have understood it, realized it, they have the concept. They can understand in chemistry, A-level chemistry, without any difficulty, but result is low. I mean, understand? I think you understand my point, right? So therefore, if you think that you have, the confidence is quite low, it's okay. Only thing you have to do, just prepare for that one. Just prepare for that one. Then, as I told you, your effort is the main thing here. You should be talented, it's okay, but not then very high talent one. Right? Normal average result is pretty enough to continue this and have a very good result at the end of the day. But you need that background. Therefore, if you don't have it, better you go through that one and refer it and prepare for that one. Now, we don't need it. Once you need it, I will mention it. As example for calculation, before I start unit 3 calculation, you need to refer some stuff in O-level science. Without that, you can't understand the concept. So likewise, where it is important, then definitely I will mention. Now you don't need, everybody. Today, did you understand the concept here? What I explained? Is there anyone who cannot understand or very confused? No, you can understand the concept. So likewise, then we continue this in this manner. Everybody can understand the concept, and I go to the complex situation step by step, slowly. The smooth movement is there. Don't worry. Right? So what we discussed today, actually, we started the history. We went to first, then 440 BC, about Empedocles' idea. Thereafter, we came to Democritus one. Next plan, go to Dalton's atomic theory. But before we go to Dalton's atomic theory, we discussed two experimental evidences to prove that the concept given by Democritus is correct. Up to a certain extent, it's correct. What are the evidences? One is discontinuous nature of matter. Other, we didn't discuss electrical nature of matter. Therefore, next day we will first complete electrical nature. Then we move to Dalton's atomic theory. So likewise, then we move from one model to the other with the experiment, with the observations, these things. It's not difficult. This is very, very simple journey. So then before I finish it, any of you, I mean, do you have any other doubts regarding this or anything to be clear? Understood. Very well. Okay, good. No, right. Then if you have any other clarification, then you can just send me WhatsApp message so we can communicate in that manner also. I think that's enough for the day. Good night. See you next week. Okay, welcome. Good night.